Okay, so we are doing for today a whole bunch of different forms of equations. The first one is called vertex form, and it's the one you're familiar with. It's the one I wrote in green on the board there. And these are different forms of a quadratic. Vertex form is the one that shows you it moved to the right 1 and down 4. It looks like this graph right here. And that little axis of symmetry line that runs right down the middle, it goes through this part of the vertex. Now I want you to make this correlation. That means that that 1 there is x equals 1, and that is the axis of symmetry line. That means if I give you a different vertex, let's say I said this was the vertex over here. I have a different parabola that's like upside down and goes through that. Do you get that 5, 1 has buried in it the axis of symmetry 2? It would be what? X equals 5. Very good. The axis of symmetry goes with the x of the vertex. All this stuff kind of goes together, and hopefully I'll help you see how it all goes together. All right, that was called vertex form, where you're basically focusing on the vertex. There's another important spot here and here. Those places are called the x-intercepts, also known as the roots, also known as the zeros, also known as the solutions. Anything that's got 4 names is probably a big deal. Who can write me the equation for this parabola using those 2 things? Okay, I'll give you a hint. Using those 2 things. Still nobody? I think you're going to see it when I do it. Oh, in the back. X plus 1 and x minus 3. You are so right. Do you get that he's got this 3 in here, but he's got the opposite of it? Doesn't that kind of make sense because it's on the inside of a parenthesis? When you're on the inside, things are opposite, right? And he's got this negative 1 here, but he's got it as a positive 1 because things on the inside are the opposite of what you'd expect. Okay, last thing, that's called factored form. And so the other one is called vertex form. This one's called factored form because, see, it's been factored. And the last kind isn't something you can just get from the graph. It's something you can get from one of the other equations. The last form is called, when I multiply this out, form. What? When you multiply this out form, what are you talking about? Watch. When I multiply this out, x squared minus 3x plus 1x, put them together makes minus 2x, and the last make minus 3. That form. When you multiply it out, form. What is it actually called? That's a good question. What do you think? General form. Yes, somebody said it. General form. And generally, you just multiply the other one out. By the way, this one that was in vertex form, you could have multiplied that one out too. It would have done the same thing. This is over right 1 and then down 4. If I multiply this all out and add it all up, guess what? Comes out the same thing. So you take one of the other forms, multiply it all the way out, you get general form. All right, now let's talk about what's good for what. There's a slide on this, but let me just do a preview to the slide. If I have this form, it told me 2 things. It told me the what's. The zeros, the x-intercepts, not the vertex. That one doesn't tell me the vertex. This one tells me the x-intercepts, where it hits the x-axis. See, this one would hit it at negative 7 and positive 5. And then it's probably like this. So this form is good for telling me the x-intercepts. This, if I multiply it all the way out, x squared outside inside plus 2x minus 35. Do you get what I just did there? Just multiplied it out. That's called general form. Generally, you just multiply the other ones out. What's it good for? The main thing it's good for is it tells you the y-intercept really easy. Finish this sentence for me. The y-intercept is where x... No. Y-intercept is where x equals 0. So if x equals 0, do you get, I put in a 0 here, and then the y-intercept must be negative 35. So the y-intercept is where x equals 0. That's a powerful thing to know. And the converse is also true. The x-intercept is where y equals 0. So I want you to say those with me one more time. The x-intercept is where y equals 0, and the y-intercept is where x equals 0. Good. That'll help you remember it. All right. So now I've showed you factored. I've showed you general. What kind didn't I show you yet and talk about its benefits? Vertex form. All right. If I want vertex form, that's a whole day of me showing you how to get vertex form unless we tell you the vertex. Now, if we tell you the vertex is 2 comma negative 5, it's not hard at all. You can go y equals, this one has been moved over right 2, so you go x minus 2, and then it's been moved down 5. Do you get how I got that really quick if I know the vertex? If you tell me the vertex, it's easy peasy. But if I don't tell you the vertex, it's way harder. Well, for today, all I need you to know is recognize that that is called vertex form. And what's good about it is I know the vertex. Don't forget, opposite of what you'd expect. So it's not negative 2 comma negative 5. It's actually what? Positive 2 comma negative 5, because it's the opposite of what you'd expect. The vertex x part, the part that's on the inside, is the opposite. All right. Good. You've learned as much as you probably need to know for today about the hard stuff. Now, there's a couple little easy things I need to clean it up at the end here. And this, again, lists the benefits of vertex, general, and factored. If you're more of a I like to see it written out type person, there's your list of the things you'd have to know about those three forms. Which one of these is a minimum or a maximum? The blue one or the red one? Which one's a maximum? Blue or red? The blue one has a maximum. The red one has a minimum. So you don't have to spend much time on that. You have to know the difference between a high spot is called a maximum. Easy. How about this? The axis of symmetry. It's that line that runs right down the middle. Just don't forget that these axis of symmetries are always x things. So this is the y-axis, but it's x equals...
Like the axis of symmetry?
Ooh, I like it. That's kind of like my vertical and horizontal. Have I told you those yet?
Yeah.
All right, anyway. But back to the axis of symmetry. I like it. I like it a lot. X equals what in this case? It runs right down the middle? 0. X equals what in this case? -1. And x equals what in this case? 1. So the axis of symmetry, I'm going to definitely steal that one. Jack, that's a good idea. The axis of symmetry. All right. And the last thing, how do I identify the axis intercepts? What? Is that the x-intercept or the y-intercept? And the answer is yes.
Okay, thank you so much.
It's both of them. When they say the axes intercepts, they're saying, I want to know the x-intercepts and I want to know the y-intercepts. When they're on a picture, I hope it's pretty obvious. That's the y-intercept because it hits y there. This is the x-intercept because that's where it hits x. Okay? This is the y-intercept. These are the x-intercepts. This is the y-intercept. And wait a minute, it doesn't hit the x. Then there just aren't any x-intercepts, and it's okay. That's the kind where the quadratic formula would come up with a negative under the square root. They're imaginary. And just like all imaginary things, imaginary roots can't be seen. Kind of like imaginary things like leprechauns. You know they're there, but you just can't see them. All right, anyway. This first one is kind of a trick question. People think it's what form? What do you think right off the bat? You think it's what form? I hope you're thinking factored form, because see those parentheses? But it's not factored form. Why? Because it's got that extra -9. You can't have an extra number at the end if it's really factored form. That was a pretty cheap shot to put at the very beginning. That's a none. No, it wasn't vertex form either. The next one, this guy that I'm circling in green, that one's vertex form. And what is the vertex, by the way, on that one? 2 comma -2. Good. Okay, that one's vertex form, so I'm bringing it over here. Now, some kid last hour figured out how to snip this, make a copy of it, and then drag it to the right spot. If you know how to do that with your iPad, I think you just use the lasso tool and then say copy. Have I got that right? All right. Then, I'd like you just to move these next 3 into the right spots. I'll circle them in red. Please move this guy to the right spot and this guy to the right spot using copy and paste with your little lasso tool. If you need help on that, ask the kid next to you. It'd be good for you to know how to do that. I'll pause while you try those. Okay, we have identified that this one was actually both general form and vertex form, and its vertex would be at 0, 3. And then this one was just a weird looking vertex form. All right, now off to the homework. And here it is. And since we have a little less time than normal than I did in my first hour class at a minimum, I am going to cut out a couple questions for you. You may cut out this last one on this page, number 3. Got that one crossed off yet? And then you may cut off this one in both sections on the next page, as in the equation. Here, I'll separately cross them out to keep from confusing you. You can skip this one and that one. I think that'll keep your assignment reasonably sized. It's still on the longish side, but I'm willing to do some of it with you too. So let's get this started together. Okay, doing number 1. The vertex on this guy. Oh, that's pretty easy. It's this dot right down there. What's it at? -1, comma, -4. Its axis of symmetry. You don't even have to look at the picture. It's this. Its axis is the axis of symmetry. I'll steal that. Thank you, Jack. And the axis intercepts. What? That's the x and the y intercepts. Okay, the x int there's 2 of them, -3 and 1. X equals -3, x equals 1. I know some of you probably just wrote -3, 1, but that looks like a point. I want you to write a point for that. It's 2 points. -3 and 1 are the 2 x-intercepts. And the y-intercept is where x equals 0, and it's right here at -3, 0, -3. You can just write -3, that's okay. Now, if they ask you to put it in a point form, then you'd have to say the y-intercept is where x is 0, right? So 0, -3 is actually the best way to write it, because it's a dot. And the y-intercept is where x is 0, so it's 0, -3. All right, you were again skipping number 3, so we'll just move on to one of these other ones here. Let's do number 4 together real quick. Clearing my ink. So vertex. Oh, there it is. If you can't find that by now, I'd be pretty sad. The equation for it, I recommend you write it out as like this before you even start. You know it's a quadratic, right? Now, it's been moved where? Right 1. And also up something. Up what? Up 7. Who notices something else about it? Yes? It's flipped. Over which way? Vertically or horizontally? I asked that on purpose because I know horizontal would be on the inside, vertical would be on the outside. High vote, remember? Was it vertical or horizontal? It was a vertical flip, a vertical reflection. Therefore, it's a negative on the outside. And last but not least, the thing that was one of the hardest things to figure out is the stretch. But remember, it's always going to only be simple things that they were stretching by. We're not going to make you stretch by some weird factor. Is there a dot right there? No. And therefore, I know this one's been stretched. It should go over 1 and down 1, but it goes over 1 and down 2. So, stretch of 2. There's a 2 out front. That last 2, I get how that might be hard. But the rest of it shouldn't have been too tough. All right, now from that, what's the vertex? Well, there you go. Those 2, except it's not -1, 7. It is +1, 7. The axis of symmetry, as soon as I have this, 1, 7, I know my axis of symmetry. It's right there. Or I can go over to the graph like this and go, okay, it's like the y-axis, so it's x equals, or it's the axis of symmetry. I really like that. Okay, and then the y-intercept, I can get it by sticking in x equals 0 right here. Or I can just go look at the picture and figure out what the y-intercept is. Oh, it's right there. A lot easier if you have a picture. The y-intercept is at 5, I think. That's 5. Yeah, that's where 5 is. And if they wanted it in a point, yeah, y-intercept is where x is 0, so it'd be 0, comma 5. All right, this is a very rich, dense, like there's a lot of topics in here. Totally okay to ask me questions if you're stuck on something. At least I wanted to help you get started. Feel free to come up and ask questions if you have them. That's all I got for the video for today.